Alright, this tutorial will once again demonstrate camera projection in Fusion. This time, however, I'd like to show you how to use these projections to remove stuff from the image. So-called key prep or cleanup work is a common task, whether you want to remove wires, shadows, or just stuff people forgot to remove from the set. Using the paint tool on a frame-by-frame basis is usually too time-consuming, and sometimes it's simply impossible. Camera projections based on a 3D match move allow us to paint one or more clean plates, which will be transformed to match all the other frames that were not painted manually. So take this shot here. Let's assume this is for a dog food commercial. I'd like to remove my shadow from the ground as it ruins the picture. And there's some stuff over here that I'd like to get rid of. This is the end result. As you can see, the shadow is gone, and I have also frozen the dog in the beginning so he doesn't look straight at the camera. Okay, this is a home video, but to be honest, that shaky iPhone video with the horrible rolling shutter artifacts will give you way more headaches than a perfect film scan. We'll have to use some techniques that might come in handy on real projects, like Batman defusing a bomb or something. So let's get started, shall we? First, I've put this footage through SynthEyes, despite the rolling shutter. The track I got was matching quite well, at least on the ground, and that's where I need to focus my work anyways. As you can see in the spline editor, the camera track is very shaky and irregular. But this doesn't matter as long as the trackers stay on the ground. I can play this back while looking through the camera in a 3D viewer. Or I can render it. The points of the point cloud will only appear in the OpenGL renderer, and they might disappear due to the subsampling. A trick is to render in floating point and assign an overbright color to the point cloud. This will make them stand out more. I've also created a ground mesh in SynthEyes to project onto. You could align an image plane in Fusion, but since the ground is uneven, the camera projection might not stick perfectly if you use a plane. You can work against that by using grid warps and transforms, but if I can get a tracker mesh that matches perfectly, I'm definitely gonna use it. Since I want to project textures onto it, I'll also add a catcher node. The plane will disappear since nothing's being projected yet. We need to decide on a frame for our first clean plate projection. You need to choose one that covers the whole area you need to paint, but at the same time the angle and distance shouldn't be too different from the rest of the shot. As you will see, this often requires intersecting projections from several viewpoints. For starters, I have chosen the last frame, number 445. Create a copy of the camera and remove the animation while you're on the last frame. Then set the camera to projecting textures. I've saved the frame and cleaned it up in Photoshop. Connect the clean plate to the projection camera and look at the result. Of course, this breaks down quickly. The track is still alright, but the white balance changes and you'll notice stretching in the texture once the angle of view changes. Fortunately, we don't need to replace a lot of grass, so in this comp here I have masked off the projected clean plate to the extent that's needed to barely cover the shadow. Here's another trick to conceal the edge of the clean plate a bit better. By using a noise in a displace tool, I can roughen up the mask a bit to give it a more irregular shape. Unfortunately, the camera move is too long, so a single patch of grass won't cover the shadow during the whole shot. Before we tackle the white balance issue, we need to add more projections from different angles. In this comp that I have prepared, I have added a total of 3 clean plates with different masks. I tried to pick frames that don't deviate too far in terms of white balance and that aren't too blurry. The catcher material will merge multiple projections if you set its accumulation mode to blend and assign different priorities to each camera projection. This is the second patch I made, and as you can see, it also doesn't cover the whole shadow. In this clip you can see all three clean plates. I have tinted them so you can see that I even transition from one to the other. Animating the opacity of a projection is always a bit of a dangerous thing. I have timed the transitions in a way so they match the overall white balance changes in the shot, which basically hides the transitions quite well. I have also introduced a linear gamma workflow. The plates are having their sRGB gamma removed, and I have enabled an sRGB LUT. Working in linear gamma will enable us to easily adapt the clean plates to the changing white balance.
Unfortunately, the LUT isn't used for the 3D space, so you'll have to work on a darker looking image in the 3D viewport.
So here's how to fix the white balance issue. I've added a locator in 3D space so I can sample the changing grass color at the same spot during the camera move. The locator should stay in frame at all times, and of course it mustn't be covered by the shadow that I'd like to remove.
Using my point cloud as a reference, I've positioned the locator next to the dog.
This background tool over here has a probe connected to its color sliders, which samples the image at the 2D location calculated by the locator.
These are the steps you need to take. Use any tool with RGB sliders. A background is just the most obvious choice. Modify a slider with a new probe modifier. The probe needs to sample the linear gamma version of the plate. Connect the locator to the probe's position and adjust the size of the probe's rectangle. You'll notice that the locator sometimes doesn't update its position properly, but this is just a viewport issue while scrubbing along the timeline. Don't forget to connect the other color sliders to the probe as well. Don't go to the spline editor, since that would force Fusion to process the whole sequence just to display the curves. Instead, we're gonna bake the animation. This will take a while, but it's a one-time operation.
I have prepared this over here. The idea behind this is simple. We have recorded the absolute values of the color, so we just need to convert that to the amount of change relative to the frame where the clean plate was painted. This all boils down to multiplications in linear color space. The color gain tool has separate multipliers for red, green, and blue, and we can add expressions to that. These expressions take the sampled color values and divide them by the value at the reference frame. This will match the clean plate's shifting white balance perfectly and automatically. There are two other things that bothered me in this shot, and I'll give you a quick rundown of the final comp. That stuff in the bottom right corner, for example. I have added another projection for this. Since it is located in the extreme corner of the image, I had to use a plane instead of the geometry that I had exported from SynthEyes. The projection is sliding a bit as well, probably due to lens distortion or the camera track not matching perfectly in this area. If you step through the comp frame by frame, you'll notice moments where the piece of grass I've projected doesn't follow the camera correctly. To fix this, I've used a simple transform tool to fine-tune the position of my piece of grass. If you put the comp and the footage into a viewer's A and B buffer, you can quickly check if your patch is aligned properly by toggling back and forth. And by using the cursor keys on the keyboard, you can fine-tune the position. The other thing I wanted to fix was the dog's head in the beginning of the shot. He's looking straight at me before turning his head. Imagine your job is to add a giant can of dog food over here, and your art director wants the dog to look at it during the whole shot. Piece of cake. In SynthEyes I have created a tracker right at the dog's feet, which helps me to place an image plane there. On this plane I've projected a still frame of the dog on frame 200. That's right after he has finished turning his head. After that frame I'll use the original plate, but before that the head will be covered by a still frame. I was fortunate that this shot didn't require me to create a clean background first. I was able to just slap the still frame on top and it covered up the edges. Usually, you would need to apply film grain to all the projected patches, but in this case I didn't bother. So, that's that. Thanks for watching.